last video, I had said that we have to do practice questions. But the thing is, I was going through the notes and I thought that we should start with how we can input multiple inputs into AND gate, OR gate, NOR gate, NAND gate, and yeah, XOR gate, and XNOR gate. So here in this video, we are going to focus on AND gate, OR gate, and then NAND gate and NOR gate. So how are we going to work with this? That's what I'm going to teach you now. So here, okay, here, um, first of all, let's talk about AND gate. Yeah, let's talk about AND gate, which is we had studied already. In AND gate, we know if there are two inputs. Okay, so in AND gate, if there are two inputs passing through a single AND gate, yeah, let's say these are the inputs A and B, the output will be A dot B. Okay. If there are more than two inputs, for example, let's say we have one, two, three inputs like this. Okay. What happens here is actually you can have three inputs together. Okay. We can have three inputs together and the output will be A dot B dot C. Okay. So this is how AND gate actually works. Okay, so you can actually break this down into a little bit simpler diagram. How you can do that is, let's say we have A, B, and then C. Okay, so what you can do is you can run. Okay, whenever you're drawing a diagram, this is a standard method that we use. We just draw the input like this single lines. Okay, so wherever you connect, there you actually have that specific output. That specific input A, and A. Okay, so that's why I use this method. This is actually pretty standard. So what you have to do is you have to pass through A and B through an AND gate. Okay, so what we have to do is, so here another thing, when you're drawing diagrams, there is also another thing that you have to keep in mind. The thing is, you can actually cut through the lines. Okay, you can cut through the lines, but if you are cutting through the lines, you have to make sure if you are creating something new. Okay, if you are connecting these two, okay, to show that you are connecting these two, you have to use this specific dot. Okay, when you're drawing electrical diagrams, okay, circuit diagrams. But here, since we don't have to show that because we need single inputs, that's how logic gates work, right? We need single inputs for each input variable. So here we can draw like this, or you can clearly show that this is not intersecting with other inputs. Okay, by showing this jumping kind of thing. Okay, so you can do like this, or you can directly draw like this, because if you make a junction, you have to use a circle disk, actually a colored disk. Okay, so I will use the normal one, the jump one. Okay, I will use the jump one to make it a little bit clear. So here we have A input, okay, and then we have B input, right? We have to pass these two through an AND gate. Okay, we are passing these through an AND gate. So what will you get? Here we have A, here we have B. So the output will be A dot B. Okay, after this, since you have A dot B here, what you can do is you can pass this A dot B and C through another AND gate. Okay, you can pass them through another AND gate. So here you have A dot B and here you have C. So when you have A dot B, okay, and C, and you're passing through the AND gate, the output will be A dot B dot C. Okay, so this is how you can actually use multiple inputs in a single AND gate. Okay, hereafter, do you have to draw like this? No, you don't have to draw like this. What you have to do is you can just pass through the number of inputs that you want to pass through. Okay, so this is what we call, this is what we do in AND gate. Okay, now let's talk about OR gate. It is the same principle in OR gate also. Okay, so when we are passing through two inputs through OR gate, okay, we know the output is added. Yeah, we have A, we have B, the output will be A plus B. Yeah, so this is what happens normally. If you have to input three variables, like if you want to have three inputs, okay, if you want to have three inputs, what you can do is you can pass through three inputs without any issues. Okay, you can pass through three inputs without any issue through an OR gate. Okay, so let's say this is the OR gate. Okay, so now you can pass through all three inputs through this gate. So here we have A, here we have B, here we have C. So what will be the output? The output will be A plus B plus C. Okay, so you can actually pass through three inputs. What happens exactly here is, we are using actually two OR gates like we did when we were using AND gates. Okay, what happens here is, so let's pass through A and B through a single OR gate first. So let's draw the input line. Okay, well, input lines in this case. We have A, we have B, and we have C. So first of all, we need A and B passing through a single OR gate. So let's pass them through. Okay, so here they are passed through a single OR gate. Okay, so here we have A dot B, I mean A plus B. Since this is an OR gate, the output will be A plus B. After this, what we are going to do is, we are going to pass A plus B and C through another OR gate. Okay, so we are passing through A plus B and C through another OR gate. So here we have A plus B, here we have C. So what will be the output? The output will be A plus B plus C. So this is what exactly happens inside this single OR gate. Okay, so do you have to draw this whenever you have to use multiple inputs? No, you can just straightly use three inputs together inside. You can pass through an OR gate. Okay, what about NAND gate? What about NAND gate? How will it work? Well, we normally know a NAND gate is like this. We have two inputs. It is passed through, they are passed through a NAND gate. Okay, so we have A, we have B here. So the output will be A dot B whole thing bar. Okay, then what happens if you pass through three inputs? Okay, A, B, and C. What will happen? Okay, so here we have the NAND gate. What will be the output? Since we have A, B, and C as inputs, the output will be A dot B dot C whole thing bar. Okay, so what is happening exactly here? How can we build this using basic gates? How can we build this using basic gates? This is very important. Okay, you may think it's not important for now, but in the future when we are doing complex diagrams, complex circuit diagrams, this will be a little bit helpful for us. Okay, especially when we are working with flip-flops and latches. Yeah, so keep that in mind so that it will be easy for us to take the inputs. So here we have the A line, here we have the B line, here we have the C line. Okay, so A and B are passed through an AND gate. So let me draw that. So here we have A and B passing through an AND gate. And now C, okay, so here we have A, here we have B, so the output will be A dot B. Okay, now we will pass through A and B again with C inside another AND gate. Okay, so here we have A dot B, here we have C, so the output will be A dot B dot C. Okay, so here we have A dot B dot C. Finally, we are going to pass it through a NOT gate. So the final output will be A dot B dot C whole thing to the bar. Okay, whole thing bar. This is what happens when you're using basic logic gates. Okay, I know you can use a NAND gate here instead of using a NOT and AND, but we are using basic gates to understand what's going on. This also improves your literacy in understanding the circuits. Okay, so pause the video, draw them out by yourself, draw it again and again until you have a clear idea. Okay, now let's talk about NOR gates, how that works. NOR gate is pretty simple. It also works like the NAND gate. We know how NOR normally works. Okay, so we have A and B or any two inputs. They are passed through NOR gate, and the output will be, if they are A, B, the inputs are A and B, the output will be A plus B whole thing bar. Okay, so if you are passing through multiple inputs like this, okay, if you are passing through multiple inputs like this, well, the output will be I'll let you know. So here we have A, here we have B, here we have C. So the output will be A plus B plus C whole thing bar. Okay, so what happens inside the single NOR gate? Well, let me explain it to you. What happens is, first of all, we are passing through, well, let me draw the lines first. So we have A, B, and C. So, yeah, first of all, we have to pass through A and B through an OR gate. Okay, so they are passed through an OR gate. OR gate. So it will be A, B. So the output will be A plus B. Then what we have to do is we have to pass through A plus B along with C inside an OR gate. Okay. So here we have A plus B and C passed through. So the output will be A plus B plus C. Okay. Finally, we will pass it through a NOT gate. Okay. Which will be A plus B plus C whole thing bar. The output will be A plus B plus C whole thing bar. Okay, so this is what actually happens inside the given gates. Okay, so if you're using multiple inputs. So when you are doing multiple inputs, the truth table also changes. Okay, since there are 3 inputs, we will have 2 to the power 3 combinations, which means we will have 8 rows in each gate for each gate. Okay, when there were 2 inputs, it was 4 combinations. So we had 4 rows. Since we have 3 inputs here, it will be 8 rows. Okay, so the idea is if you have n number of inputs, okay, if you have n number of inputs, the number of the rows in a truth table will be 2 to the power n. Okay, number of combinations. Yeah, let's say number of combinations. The number of combinations that you have in a truth table will be 2 to the power n. Okay, so keep this in mind. This is very important because we will use it without any issues, because we don't have to show by breaking down. We don't have to break down simpler. We don't have to do that. You can just directly use multiple inputs inside a single gate without any issues. Okay, you can even pass through 5 inputs if you wanted. Okay, but we are mainly focusing on 2 inputs and 3 inputs. Keep that in mind. And yeah, that's it. Stay tuned. I'll see you in another video. Thanks for watching the 3rd video in our Logic Gates series. If you found this deep dive into multiple input logic gates and or NAND NOR helpful, don't forget to like, share and subscribe for more lessons. Hit the bell icon to stay updated with our latest videos. Check out the full playlist to master logic gates and follow us on Instagram. I'll see you in the next video. Until then, keep learning and stay curious. Bye bye.